Good morning, everyone. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay. So previously we have stopped here. Okay, so we have covered all these concepts. Today we will learn how to identify the functional dependencies and how to perform the normalization process. Okay, all right. So let's do this today. I'm not sure that we are going to finish today, but we will try. Okay. So previously, as a recap, we have discussed information about normalization. We said it's the concept of unnormalized relation might cause some problems like update anomalies might appear if the relations are not normalized. In normalization, there will be uh, good and set of allowable or suitable relations with no repeating groups or redundant data. Okay, so if there are any repeating groups or redundant data, the relation will suffer from some update anomalies, so there will be loss of consistency and reliability of the relations. Now, in order to have the relation normalized or get the relations normalized, we need to understand the concept of functional dependencies. As we said, functional dependencies, let me just go back to that slide. Right. So functional dependencies are, it comes into three types. Number one, full functional dependency, and then number two, partial functional dependency, and number three, it's transitive function dependency. Okay, so full function dependency, or FD, means that only value of one will find one value of B. Okay, so one to one from both sides. So one to one, a value of A will be matched to one value, only one value of B. So that means that A is functionally determines B, or determinant of B, or we can read it from the other side. B is functionally dependent on A. It's full functionally dependent on A. So if D means full function dependency, where one value from A, this is an example, A to B. Okay, so one value from A will be finding only one value from B. Okay, so it's one to one only. This is the meaning of full functional dependency. Okay, now when we talk about some other attributes that are partially dependency, that are having partially dependency, if there is some attributes that can be removed from A and still the dependency will be holds. Okay, will be hold. So like, for example, when staff number and staff name both determines branch number. Okay, one value, there must be value from staff number and value from staff name will be finding one value from branch number. Okay, so one, A, B, and C. A and B are determinants of C. This means that it's partially dependency. Okay, so this is partial dependency. How about transitive dependency? We said transitive dependency when A determines B, B determines C, then C is transitively dependent on A through B. Okay, that was what we have discussed previously. So these are three types of functional dependencies. We need to understand them, and then we can identify them within the relation. Now, if you want to identify the function dependency, if there are no enough information within the enterprise or user requirements, you need to understand the relationships between these attributes. For example, this staff branch relation, this is an unnormalized form of the relation. We need to understand the relationship between, for example, staff number, staff name, and branch number, for example. Okay, we need to understand the relationship between branch number and branch address. Okay, in this case, if we have full understanding about the relationship between or among all the attributes within the relation, then there will be no problem and no difficulty in identifying the functional dependencies. So if there are no enough information about the relationship, you need to use your common sense. Okay, so think about what are the relationship, what are the dependencies that can appear in this relation. Okay, let's see how we can identify the functional dependencies in this relation. For example, in this relation, we can find how many attributes we have here. We have, in a staff branch relation, we have 6 attributes. All right, 6 attributes. How we can identify the function dependency? We can determine, for example, first function dependency, we can see that staff number, okay, is a determinant for all, right? Like, because it's a primary key, so it will be determinant for all. So staff number will determine staff name, will determine position, will determine salary, will determine branch number, and it will determine branch address. So this is primary key relationship. All right, so primary key relationship means that the primary key attribute will be determinant for all other attributes. Okay, so this is number 1. This is number 1. What we can see also here, we can see another functional dependency, another relationship between attributes, close relationship. We can see that branch number determines branch address. Okay, so this is another one. And I'm going to tell you what are these types. Yani, what is the full function dependency? What is the partial? What is the transitive? Okay, so we can see that this is another functional dependency. Okay, branch number can determine branch address. All right, so this is number 2. At the same time, we can also read it from both sides. When branch number determines branch address, also at the same time branch address determines branch number, one-to-one relationship. Okay, it can be from both sides. For example, 22 Deer Road, London determines B005. At the same time, B005 determines 22 Deer Road, London. So it works in both directions. All right. Now, this is third one. So this is third function dependency. And how about 4? We can find, using our common sense, we can say that branch number plus position, okay, both of these determines what? Salary. Okay, if I know which branch number I belong to or a member of staff belongs to, if you know which branch number, for example, main branch or main office will be different. Okay, so branch number plus position will determine salary. Okay, in case the enterprise has another policy about salaries based on the branch number. So both branch number plus position will be determinant for the salary. Again, when we say that branch number and branch address that are both can be determinant for each other. We can say also branch address and position determines salary. Okay, so this is how we can identify the functional dependency based on the relationship among the attributes. So how many functional dependencies we have, or how many relationship between attributes we can find here? We can find 5 functional dependencies appearing in the staff branch relation. Got the point? Just generally, did you get the point? How I identify these relationship between attributes? Did you get the point? Just use your common sense. Just we can use our common sense, or if there are some information provided by the enterprise, we can use it. Otherwise, we use our common sense to understand the relationships. Okay, so always you need to know that the primary key attribute will be determinant for all other attributes within the relation. This is the first functional dependency, and we call it primary key or PK. Okay, now let's see another sample relation. Another sample relation, when we want to identify the functional dependencies in this sample relation, you can see, for example, I can identify the first functional dependency based on the values appearing in each of these attributes. For example, I can see that when A, let's just have it this way, when A small appears in A attribute, I can see that Z appears in C attribute. Okay? The same time, when Z appears in C attribute, always A appears on in the A attribute. Okay? When A small appears here, Z appears here. Same way, Z appears here, A appears here. So it's what? It's 1 to 1. Okay? It's 1 to 1 relationship. Okay? So we can know that A is a determinant for C. Okay? It's a determinant of C. And at the same time, C, I can say C is a determinant of A. And it works in both directions. Why? Because always one value of A finds the same value of C. One value of C finds the same value of A. That means that this is number 1. We can find also here we can see E. If E appears, R appears on C. If R appears, E here. Okay, so it's 1 to 1. So this is number 1, 1 to 1. So we can say that the first functional dependency here is A determines or functionally determines C, or the second one, C functionally determines A. Okay, same way. So this is number 1. This is number 1 and number 2. 1 and same time. Functional dependency number 2 is when C determines A, because it's 1 to 1. We can find same value every time. All right. Now let's look at B as a sample here. Like, let's talk about B. B, when B appears in B attribute, when B small appears, we can see that W appears in D. Okay? Same way, when W here appears, then B is here. Another values or 2 more values can be seen for W. D and B, both B and D are finding W, both. Okay, so 2 values of B, which are B small and D small, are finding W. Okay, so it's what? It's like from this side, it's 1 to many. Okay, and we can find F, finding S. Okay, so there will be a functional dependency or relationship between B and D, and we can see that it's like B is functionally determines D. All right, B is functionally determines D, but not in other direction, because there are more than one value here determines the same value from the other attribute. Okay, so it's just B determines D. How about the last one? We can find that if two values appears in A and B, that will find another value in E. So this is another function dependency. If you look at it, you will find it. So we can find both from A and B, like for example, A and B, okay, E and B. Let me just find something, yeah, in common. When A and F appears, then T will be found in E. Same way, when A and F appears in A and B, T will be found in E. Okay? When A and D or A and B, sorry, when A and D and A and B, Q will appear. Okay, so this is how you can just look at, this is just a sample relation. Yani don't worry about A, B, don't be confused, but it's just there because they want to tell you that there are relationships among these attributes. Okay, and how we can identify it? By looking at the values and the relationship between values. Okay, so we can find that two values, when two values appears in A and B, another value will appear or will be found on this DE. Okay, all right. Now, how many function dependencies we found? We found 4 function dependencies in this sample relation, just 4, based on the relationship between attributes. Well, this will differ based on the requirements, user requirements, enterprise information. Again, I can say that it's your decision. If you are performing the normalization process, it's your decision that you can decide the relationship or function dependencies between the attributes based on the information provided or your common sense. Okay, now here we have same. When A appears in A, we can say when A value appears in A attribute, Z appear in C. Same way, when E appears in A, it appears R appears in C. Okay, so A determines C. This is one. C determines A, as we said. The third one, B determines D. A and B determines E. Sorry. Okay, so these are 4 function dependencies from the sample relation. All right. 4 function dependency, we can say FD1, FD2, FD3, and FD4. Now, how we can decide which type of function dependency? Which type of function dependency are they? We can decide based on the values held by every attribute. If there is always full function dependency, only one value determines one value from other attributes, this is full function dependency. Okay, so only one value, if we say only one value determines, see from the sample relation, this sample relation, only one value determines one value from B. Sorry, A determines Z, A determines Z, and Z determines A. So this means that it's full function dependency because only one value finds only one value from the other attribute. Okay. But while the partial will be held in 2 attributes. If one attribute is not there, not existing, then the dependency will be held and it will not be removed. So if you two attributes, for example, this one, A and B both determines E, okay? So if one, for example, is not there, still B is there. If A is not there, still B is there. So that's the meaning of partial. There is part of it. So E is partially dependent on A and B, partially, okay? Because there are two attributes are there involved in this relationship. Now, what is the main purpose of identifying a set of function dependency? Why we identify the function dependency? Because we need to also identify the set of constraints in order to start doing the normalization or performing the normalization process. So something also to be determined along with the function dependency, we need to identify the integrity constraints, and which is primary key. Okay, so just focus with me. The steps of normalization starts with number 1, identify the functional dependency, FD. Okay, number 2, identify the primary key for each relation. Okay, and then comes the normalization. Okay, I will just have in. Got the point? First, you identify the relationship between attributes, which is known as functional dependencies. Okay. Number 2, primary key for each relation. Number 3, start the normalization. Okay. Now let's see how we can identify the primary key. For example, for this relation, what is the primary key for this relation? What is the primary key here? Anyone can tell? The candidate key that is uniquely identify each tuple. What is the candidate key? The only candidate key that uniquely identify each tuple. Which one from the staff branch relation? Which one? This one, right? So yes, exactly, Mariam and Qasim. Thank you so much. So it's staff number. Staff number is the primary key for this relation. So staff number can be the primary key for this relation. All right. Now in this sample relation, who can tell? In this sample relation, who can tell? Based on what we have found from the function dependencies, we found that A determines C, B determines D, both A and B determines E. So using this information, what do you think? What is the primary key for this sample relation? A or B or what? Here you can find that A determines C and B at the same time B determines D. At the same time both determines E. So this means that both A and B are they are composite key, okay? So both are like the composite key or the primary key that determines all other attributes, okay? In this sample relation, we can find that based on the relationship among the attributes, we can find that both A and B are the primary key that uniquely identifies each tuple. So both are primary key, or we call it composite key. All right? Based on the relationship or the functional dependencies. So together, they can be A and B as a composite key. Okay? So both are determinants. Got the point? Why we decide that both are determinant? Because you find that if both two values appears in both, then another value will be found in all of these. Okay, so both can be determinant for other attributes. Okay, now let's talk about the process of normalization. How we normal technique we can analyze, in which we can analyze the relations based on their primary keys and functional dependencies. Okay, so the technique that can be performed by analyzing relations based on their primary keys or candidate keys and functional dependencies. All right, why we say candidate keys? Because sometimes primary key becomes a composite key, okay, in some relations. So based on the primary key and function dependencies, which means the relationship between attributes, we can analyze the relations, and we can have or run some series of tests among the relations in order to reduce any of repeating groups. And yeah, if we decompose it into relations, then the requirements for the normalization will be met. Okay, so what is normalization requiring from the relation? It requires that there will be no repeating group or redundant data among the relations. Okay, if this requirement is not met, then it must be what? Decomposed into other relations. Okay, it can be decomposed. Decomposed means we can divide it from larger relations into smaller relations. All right, this is the decomposition. Decompose means we can separate some attributes with close relationship into smaller relations, and that will be based on their functional dependencies. All right, now how many normalization form or tests we need to perform in this chapter slide? We will just focus on the third normal form. Okay, so all normal form will be based on the functional dependencies, all of them except first normal form. Why first normal form is not included? Because in the first normal form we are not going to focus on the function dependency, we are just removing the repeating group. In the first normal form we are just removing repeating groups, and I'm going to tell you how we need to fix the fix the relations with repeating groups. In normal form, beyond third normal form are very rare. That's why we are going to focus on the first three normal forms. And as you can see in this figure or in this illustration, you can see that there are so many processes for the normalization, starting from the first, second, third, and a special kind of normal forms, fourth, fifth, and higher normal forms. This is very rare, okay? From here to there, it's very rare to have relations in these or requiring having all these levels of normalization. Most of the time, okay, and or generally it's only requiring the first three normal forms. Okay, and the relation after the third normal form will be stronger, will be less vulnerable to update anomalies. There will be no problems related to inserting anomalies or deletion or modification. Okay, so let's talk about the normalization as a bottom-up approach. Why bottom-up? Because we are not starting with the main relations, we are starting with its elements, okay, with its characteristics. So we start with the attributes, so that's why we say it's bottom-up. Bottom-up, we start identifying the attributes, the functional dependencies among attributes, the primary key, then we comes out with the relation. All right, so we start with the user requirements as a first stage. Then we have this diagram is summarizing the whole process. All right, so this is very useful for you. Now after knowing the user requirement, and you can have the data source, for example, from the organization or the enterprise, and then you can convert it to a normalized form or UNF. So this is the first process. You can get the data source, and then you can transfer it to a normalized form. Then in the unnormalized form, if you want to convert the unnormalized form to the first normal form, what we need to do? Remove the repeating groups. All right. So we remove the repeating groups. Then if we want to, if it's still the requirement for normalization is not met here in the first normal form, we can convert it to its second normal form. And what does it mean? Number 2, second normal form, by removing any dependencies, partial dependencies. All right. So we remove the partial dependencies. All right. Now, in order to convert the second normal form to its third normal form, the relation will be including, in the second normal form, there might be some relations including transitive dependency. So number 3, we remove the transitive dependency. So in summary, the normalization will be in 3 processes. Number 1, converting UNF to, number 1, from UNF, a normalized form, to first normal form. How we can do it? By removing repeating groups. Okay. Number 2, from first normal form to second normal form. How we can do it? By removing the partial dependency. Number 3, from second normal form to third normal form. How we can perform it? By removing the transitive dependency. All right. I'm going to show you, inshallah, next time how we can do this, how we can identify the functional dependency and remove any repeating groups, how we can remove the partial dependency or transitive dependency. And then in the last stage, there will be all relations normalized with no update anomalies, and which are not suffering from any update anomalies, and it will be fully normalized. All right, so we will have an example about this process. For now, you know how to, you know, the basic information or basic concept about normalization. All right, so inshallah next time we are going to discuss this on I'm going to provide an example and how we can do this. All right, next few slides will be about an example. All right, now do you have any question, guys, girls? Do you have any question? That was all for today. And let me, in the last 5 minutes, I need to make sure that all of you are joining a group of project, because you know we are running out of time. And let me just check. I have assigned all of you in 10 groups. Let me show you. I'll just share the screen. Okay. See, I have assigned you to groups. So the course groups, I will also provide you for each group. I'll just need you to know the number of your group, okay? So see, what is the number of your group? You are assigned to groups. You can go to course groups and you will find the project groups. You will find your project group, okay? Your project group. So I have assigned you all to groups. For example, group number 1, Ghadir, Abdullah, Usama, Bassam, Zainab, Mohammed, and Sarah, Usama. 4 students are there. Okay? Just a minute, Qasim. Yes, you can. Yes. Yes, exactly. You can be specific. And I prefer that. It's recommended to be specific, to talk about or do about a specific or particular place. This is a good idea, Qasim. Okay. Now, group number 2, home library system. By the way, there are some groups without a topic. So please make sure that you have a topic for your group, okay? Please let me know. Let me know about it. Send me on Teams, please. Okay? You can send me a Teams chat and notify me about your group topic. Also mention the members, please, if you are not joining a group yet. So I am just reading the names here. Group number 2 are students. Members of group number 2 are Aliya Mahmoud, Abdul Mannan, Fatima Abdul Hamid, and Noor Muhammad. Okay, these are 4. Group number 3, cold store database system. Jinan Yusuf, Al-Miqdad Saleh, Qasim Hassan, and Ahmed Sadiq. Group number 4, clinic database system. Hajar Ahmed, Ali Abdul Hussein, Ali Abdul Jalil. All right, there is one more missing here. I don't know. Is it who is missing here, guys? Let me just no, I don't know. Hajar Ahmed, Ali Abdul Hussein, Ali Abdul Jalil. I have assigned it to 4, I guess. Okay. Anyone from group number 4, please, guys? Let me just check. Ali Abdul Jalil. Ali. Let me just check. Hajar is there? Not there. Ali Abdul Hussein and Ali Abdul Jalil. Yeah, maybe. But let me know, please, guys. Ali Abdul Jalil, are you there? Ali Abdul Jalil, please let me know who is with who is the 4th member for group number 4. Hajar, Ali Abdul Hussein, and Ali Abdul Jalil. Okay, just let him know in the group, please, guys. Let anyone of group number 4 member, okay, Hajar or Ali Abdul Hussein or Ali Abdul Jalil, let them know that let them contact me on Teams, okay? Please, group number 4. Okay, let we read the other one. Number 5, group number 5, Muhammad Adil, Muhammad Abdul Mun'am, Ali Abbas, and Ali Hussein. Okay, that's good. Group number 6, Manar Hani, Yusuf Muhammad, Ibrahim Salah. I guess they are maybe they have dropped the course. I don't know. I'm not sure. Maybe if they drop the course, then they will not appear here. Manar Hani, Isa, Yusuf Muhammad, Ibrahim Salah. Group number 6, please, one of you, Manar or Yusuf or Ibrahim, please contact me on Teams. Okay? Let me know about your group topic and your problem description, please, as soon as possible. Guys, any one of you send them on WhatsApp group, please. Group number 6 and group number 4, okay? So group 6, any one of them, Manar or Yusuf or Ibrahim. Thank you, Qasim. Let them know and let them contact me. Group number 7, cold store database, Huda Abdul Rasul, Zain, Ali Saeed, and Fatima Majid. That's good. But please provide your group description. Group number 9, Fatima, Qais, Naba, and Maryam Khalifa. Also, I have Abdullah, Muhammad Ali, Ibrahim. Muhammad Ali, are you there? Muhammad Ali Ibrahim, he's not there. Please let him contact me. Muhammad Ali Ibrahim, okay? Now I will reschedule these groups based on the new. Okay, yes, Abdullah. Thank you. I will let you know today, Abdullah. If you are not joining any group yet, I will assign you to one of these groups, okay? Just let me know about Muhammad. All right, let him contact me. If you move members, membership, okay. They must be there. They must be there. Okay. Now, do you have any questions so far, guys? Anyone needs. Okay, if he is assigned to another group, let him contact me. Okay, let him contact me. Let him inform me because I'm not aware yet. Okay. خلاص إن شاء الله عيال أنا راح أشوف بعد الفورم. I will look at the form again and maybe they fill the form again and I will reschedule or reassign members to groups. Please, I will create folders for each group and I want you to provide or upload any of your meetings if you are having, because it's required for your project that having meetings. Okay, so if you meet for example, if you meet whenever you meet on Teams, for example, online, please provide some notes or meeting minutes for each group and you can upload it on your group folder. Okay, it will be the end of this semester, Qasim, which means يعني we are running out of time. It means that if we have end of May, because the last day will be 28th, yeah, 28th of May, or let me just check. No, sorry, 26th of May. 26th of May will be last day, I guess, in this semester. So we are having our already we have 1 week for Eid, inshallah, from 1 to maybe 4. I'm not sure. Maybe from 1 May to Thursday to 5th of May. So this is wasted. We have we lose 1 week. Yes, we are running out of time. So please be serious, be more serious about your project, okay? And let me know if you have anything, if you have any question, just contact me on Teams. All right. I have talked about the project Abdullah once. I'm not sure. Let me just check the chapters. Okay, there are instructions about the project. It's uploaded on Teams. Not sorry, on Blackboard, not Teams. Okay, I guess we have finished. The time is up. Okay, so do you have any other question about the project? I will try to يعني I don't know because I need to cover also cover these topics. Okay, let me just take the attendance. All right. Okay, يا جماعة, thank you so much for attending today. That was all for today. Thank you so much. الله يعافيك إن شاء الله. انتم بعد يعطيكم العافية. Thank you. May Allah bless you all. Thank you. If you have any question, you are welcome. If you have any question, don't hesitate to ask on Teams, okay? Just send me a chat and inshallah I will answer you on time. Thank you so much. Bye bye. Take care.